floor is given to Martin Lenk, Director of the Department of Services of Federal Agency of Cartography and Geodesic of Germany. He will tell us about BKG, the national supplier of geospatial data for urban development in Germany.
Thank you very much. First of all, can you hear me? Can you hear me? Oh, good. Fine. I will open my presentation. I hope it will work. Can you see my presentation now? Oops, I opened the chat. Do you see my slides?
Так, видно.
They should be there. They're on my
Yes,
screen.
we can see
Yes.
your presentation.
Ah, yes, very good. So, thank you for my invitation, for your invitation and the possibility to present here in this session. I'm the head, just about myself, of the service department of the National Mapping Agency, BKG. My personal background is geography and water engineering. Before I start the presentation, I think this is appropriate. I'd like to express my solidarity with the people in Ukraine. And as you know, we stay next to you, and I hope this incredible war on your territory will end as soon as possible. I hope this is okay and acceptable to say that before I come to my slides now. With the following slides, I will only focus on two activities of BKG, our satellite mapping service, which is an interesting tool for federal agency, for our government, and our digital twin project, which is a bit in line with the technology which we've just seen in the presentation before. First of all, I'd like to say who we are at BKG. Wait a minute. And it's not so easy to handle this. Oops, sorry. So, now you see, I guess, my next slides. I hope so. On my screen is visible. Well, we are a federal agency under the Ministry of Interior of the federal government. You know, we are a federal republic with 16 states, and we have a central government, and my organization and me, I belong to the Ministry of Interior, the federal government. We are managing and providing geospatial information, geodetic observations about the Earth, like Earth rotation and so on, as well as any kind of reference or thematical spatial data, geodata, e.g. maps, or internet application like GIS portals. We are also offering trainings for our customers, other agencies in the federal body, e.g. about GIS or about any other geographical IT tools. Last but not least, we are the German representative for any kind of geospatial interest, e.g. at EU or UN level. Well, I can see that you see my slides. That's very good. Thank you for the feedback. Just skip the animation. We are located in Germany, in Frankfurt, with more than 200 people, including our leadership, our president, who sits in this nice classical building, but we also have technical buildings. And we have about another 100 people working in Leipzig in the east of Germany. We have also 3 geodetic observatories, one in Germany, one in South America, which is a close cooperation with Argentina, and a small observatory which runs automatically in the Antarctic. There are apart these observatories of a global system to observe and specify Earth parameters like rotation or continental drift. This is just that you understand my organization, and now I come to my 2 examples. First of all, to our, you can say satellite remote, our satellite mapping service. The service is done by a team which is called the Satellite Basis Crisis and Spatial Information Service, in German abbreviation SPD. The satellite team, the SPD team, is about 20 people, and they are all mapping and satellite data specialists. They are available all week, including weekends. It's an emergency service, so it's very important for us that in case it's needed, these people are already also available on the weekends. The team, they provide individual products like maps, dossiers, or even web applications for any purpose. It's key when, or for example, when there is a natural hazard like a flood. In these situations, we react immediately, gather together any spatial information which is relevant for the case or the area where it happened. We create products like emergency maps for technical services, police, or for the Red Cross. Most products are based on current satellite data and images. We can order recent satellite data in very short time frame, like in a day. We therefore work together with commercial service providers who are in charge of the satellites, and they can steer satellites in a few hours to any point where we want to have them. We analyze the data and we create a product which is needed then during a flood. For instance, situation maps about roads or bridges which can still be used. All services, and this is very important, are totally free of charge for any users from the federal administration. To explain this, citizens cannot come to us and ask for products, or other governmental bodies like municipalities. We are restricted to any federal agencies, but these are about 200 different agencies in the federal bodies. Here you see some fields of applications where we work on, for instance, here for technical support abroad, or during security crisis, for instance, terrorist attacks. We supply data maps and applications to prepare for big events, or for instance, demonstrations or sport events like a football European Cup, or political events like the G8 summit, which happens now and again in Germany. But also we provide these things and these products in case of crisis, natural hazards like earthquakes or flooding, like I already explained. We are using different data. So far, I explained that we mainly use remote sensing data, but we also use data coming from the statistics or from infrastructure, like roads or electricity, or very important sensor data, real-time data here, for instance. You see measurements from rivers. These are current levels, and in case of flooding, you can imagine these green dots, they turn into red zones, and we can tend to identify then from one moment to the other where flooding crises are coming. To just give you one example of the projects which we are creating. This is an example from abroad from 2 years ago, which we created. You might remember it was a refugee camp in Greece, in Lesbos, which burned down. In these cases, we analyze satellite data here, or in this example, from before and after the fire. With this data, we can not only see the current situation, we can also extract detailed information, for instance, about the number of tents and huts which were destroyed, or the loss of critical infrastructure like electricity or medical units on the site. You can imagine these are very crucial information for any measurements done to solve this kind of problem. On this last slide about our satellite mapping service, I basically just summarized what we are doing. I explained most of the things I do not need to repeat, but furthermore, you see at the bottom, you can see that we also support by transferring knowledge and experience about satellite technology and how to use it to our customers. This is very important for us because we want our customers to be self-independent and to enable them about the use of GIS and satellite as much as possible. And with this, I come to my last example, which I already mentioned is a little bit in line about what we've seen. That's just in the presentation before. This is just on a different scale. We are creating at present a digital twin for the whole of Germany, and this data we are not collecting from the street. We are collecting them from an aeroplane with using a LiDAR camera and collecting points from all over Germany in a resolution of roughly 20 centimeters or higher. This data here you can see is from a prototype which we've done in the region of Hamburg and around Hamburg. and you can see the outcome of this leader data, which we then use for our digital twin. We want to create this digital twin and this data set for the whole of Germany. Wait a minute, I just have something to change here on my screen. You cannot see that. Sorry. We'd like to create this for the whole of Germany, and we like to collect this data every 3 years. At the moment, we only done the prototype, but we are ready to start the flights of Germany next year, and we'd like to collect this data inside a year. The 3D model which we collect is not the twin itself. It's just the backbone data, as I call them. The twin contains much more, as you can see in this drawing. It also contains any kind of available and relevant spatial data sets for use for different applications. For instance, points of interest, road systems, statistical data, or weather forecasts. This is what I try to express here in the middle field. And last but not least, we also integrate tools for simulations into the future, like for extreme flooding or other consequences of climate change. And that will be my last part. We'll show you what I mean with this. So now my presentation is not running forward. Now it is. Here you see another animation about this approach, here focusing on the fields where the digital twin can be used. I hope it's quite clear with the data we collect and with the data storage we produce, and with the tools we integrate, that this is a universal tool for any field of applications. For instance, for agriculture, for disaster risk reduction, what I already mentioned, but also for urban planning solutions. And with this, I will come more or less to the end of my slides. I'd just like to show you or demonstrate an example which we already prepared with our digital twin. At the moment, we are already preparing a twin for heavy rainfalls. You know, these heavy rainfalls which come in a very short time frame and then are quite disastrous. They are rising in number and frequency more and more. So it's a current problem of climate change. For this simulation for heavy rainfalls, we need very precise digital elevation model data. We need data about all the buildings in Germany and also statistical data about heavy rainfall based on long-term observations everywhere in Germany. This last data received from our National Meteorological Service. The example shows, I think that the digital twin can be very useful also that the digital twin in our eyes is based on close cooperation with data providers and users for this digital twin. The outcome, and this will be my last slide, is then something what you see here. We already done the simulation for a region in Germany, in North Rhine-Westphalia. The outcomes are predictions for certain heavy rain situations which are occurring during very extreme weather conditions. So this we simulated the flood height as well as the velocity. Those parameters are important for identifying critical risk zones, as you can see. And with this, I'm at the end of my presentation. I hope interesting and useful for you. I'd just like to express, these are two examples. We provide much more as an agency, for instance, the provision of reference data, geoportal, interactive maps, and also our geodetic observatory. Thank you so much for your attention.
Дуже дякую, Мартін.